In this video, I wanted to do two integrals with bounds, or definite integrals, because sometimes this is a forgotten piece of integration. Sometimes you're so into finding the antiderivative you forget that the actual purpose of this is putting in the bounds and finding the area under the curve. So this first one is going to be by old, we're looking at this and it's to the fifth power, so you I guess have the chance to multiply it out if you wanted to, but I think our best bet is to do some substitution. So if I made u 3x minus the square root of 2, so du was just 3 dx, you'll notice there's just a dx here. It's just, this thing raised to the fifth and dx. So I'm going to divide both sides by 3. And I can now replace the dx with a 1/3 du. And, this is a video for BC, so hopefully you have seen some substitution before in another course or have watched other videos. But just a reminder, I'm going to replace this entire thing with u, because u is equal to 3x minus the square root of 2. So it'll be u to the fifth. And this I'll replace with a 1/3 du, and I'll pull that 1/3 out front. So this integral becomes 1/3 times the integral of u to the fifth du. Now, I want to talk bounds. You'll notice that up here, the bound was the square root of 2. Well, that's in terms of x. Okay, this is a bound in terms of x. I'm just going to put x bound. But now, my bound should be in terms of u. So you need to use the kind of little substitution key you've made and say, well, if I know what x is and I want it in terms of u, I just have to substitute. So 3 times the square root of 2 minus a square root of 2. Just think about that for a second. 3 times the square root of 2 minus the square root of 2, that's 2 square roots of 2. Because we had 3 of them, we subtracted 1. That's our new bound. And here, bound is 0. 3 times 0 minus the square root of 2, so negative square root of 2. So those are the bounds in terms of u. So we do the antiderivative. Okay, we've got u to the sixth. We divide by 6, so this becomes 1/18. And 2 root 2 and negative root 2, like that. Now, if you wanted to at this point go back and you said, you know what, I'm going to resubstitute right here. I'm going to put in 3x minus the square root of 2. If you're going back to x, you need to go back to the x bounds. If you're going to stay with u, which I would recommend, if you went to the work, I'm going to write u bound here. If you went to the work to find the bounds in terms of u, you might as well use them. So you plug in 2 root 2 to the sixth. You plug that in, so 2 root 2 to the sixth power. You get 512. You plug in negative root 2 to the sixth power, and you get 8. So 512 minus 8 is 504, divided by 18 is 28. So that's the area under the curve. Okay. Now, this next example, we've got a product of two functions, 3x and e to the x. And you could pull the 3 out right away if you wanted. But this is a product, and you should check substitution first, but of course substitution isn't going to work, because normally we'd make u equal to x, the exponent, and that's not going to help us get rid of this. So a product where substitution doesn't work, we go to integration by parts. Now this is a terminating integration by parts that I think tic-tac-toe method will work great for. So 3x, 3 and 0, dv, e to the x, like that. So something like that. Our integral then is just 3x e to the x minus 3 e to the x plus c. And, oh, excuse me, we don't need the plus c because it's definite. And then we plug in 1 and 0. So we find the integral, we plug in 1 and 0. So it really is no different. It takes a little bit more work to get the integral, but it's no different after that. So if I plug in 1, I get 3e minus 3e. If I plug in 0, I get 0 minus 3. Okay, because e to the 0 is 1. Well, 3e minus 3e is 0, and 0 minus negative 3 is 3. Okay, so just a couple quick examples here of definite integrals and how we can do them with some different techniques like substitution and integration by parts.